My name is Christian, and I invented the KITE engine, a device developed specifically to revolutionize both sailing and renewable wind energy.
And starts to pull, it spins this generator, and you can see the regen activate.
I'm going to take you on a really unique research and development journey. The last time, I started testing on the control system so that we could use it on a boat. The ultimate goal is to transform any boat into a mobile wind generator or a sailcraft. And with the KITE engine, I believe we can do both. And we can smash speed records and save tons of fuel along the way. But until then, I'm going to share with you all the insights and individuals I've met during this research journey. First, a man who's made a transatlantic kite boat crossing in just 25 days, solo. Second, a retired Air Force pilot that wants kite engines for his luxury line of off-grid boats. Third, a man who wants to use kite-based wind turbines for sustainable communities in Fiji. And the builder of a modern-style version of an ancient sailboat. That counts as 4. And 5, a hang glider pilot turned engineer with more experience with kite boats than anyone in the world. So, be excited. This episode will be focused more on the research side, but stay tuned and definitely subscribe if you want to see updates on the new version coming out soon, Carbon Fiber ASA.
Oh man, look at this. Sand and gears are not good, but it's actually a good torture test. It's a really good torture test to be able to see if it works. This edition is about improvements made to version 8 of the KITE engine. So the level wind system neatly lays the line back on the spool so it doesn't bunch up. This is what it should look like. The little pawls fit in the groove on the level wind and it oscillates back and forth. But it causes a lot of friction, and after time, it doesn't function anymore. So I got this new one 3D printed out of stainless steel, and it cost about $30, like a fraction of what it costs to CNC. So sand was becoming an issue, so I designed this cowling. This will inform us, these are inductive sensors, these will inform us every time the components rotate. So for example, when this annulus, this big ring gear here, this thing rotates, this light will go off and it'll tell the microcontroller that we've made one full rotation. So we need this to make the KITE engine more autonomous. This is kind of my approach to automation, is we'll have a camera log each loop and the system will be able to rotate. So next I designed more secure mounts. The last thing I need is a KITE engine flying off the deck. We beefed up these brackets here so then it can be mounted. I made these out of waterproof and UV resistant ASA. The hybrid planetary gear set was prototyped out of PLA, and it's a great material, but it's just not very resilient. It's liable to warp in the car on a hot day. So I asked my friend Stanley, who suggested glass nylon. That's nylon filament infused with fiberglass. Stanley is a mechanical engineer at Pantheon, a 3D printer company in BC. It's amazing. They've got a 300 by 300 build space, which is just the exact right size I need for this huge ring gear. Look at it. The whole idea is to bring back local manufacturing. We can get things injection molded, or we can do it cheaper and better here in the US. Near perfect overhangs, new inductive sensor ports, beefed up brake mounts. Just a great print.
the tolerances, everything shrinks. So there's a lot of experience that goes into making parts, but look at this. Absolute perfect tolerance. It's amazing.
So, after making all those improvements and a few more off screen, it's my pleasure to unveil version 9 of the KITE engine at Open Source.
Oh my God, thank you! Thank you! Hello!
So the KITE engine has been accepted at Open Source to have an exhibit alongside makers like Adam Savage, CNC Kitchen, RC Test Flight, and more. It's basically a giant science fair for adults. Everybody's going to be there, so I'm really excited. I also finished filing the patent, so we had a provisional, but we filed the official utility patent with just 3 days to spare. Now I can officially say the KITE engine is patent pending. In other news, we found a boat to mount the KITE engine on, a 50-foot monohull, Douglas Thorpe of CEOP, I'll let you know about them more later, saw the previous video and offered some genuine support. The boat is called Argo and it's located near LA. It's specifically designed for research and education for kids, and its programs even show kids the ocean for the first time. Now, what if we could build KITE engines out of sustainable recycled plastic?
To do some more tests and show you that this is an underrated material. So the most straightforward machines that you can find online are simply an old 3D printer hot end.
PETG is actually the same material in plastic water bottles. So I've actually been thinking about getting in contact with the ocean cleanup.
System 03 is massive, spanning a length of 2.5 kilometers across, and is currently capturing floating plastic pollution in the Great Pacific Garbage Patch, located between the states of California and Hawaii.
Now on the emissions side, at this point in time, we are compensating for all the carbon emissions that our vessels emit.
With KITE engines, we could transport plastic, we could save fuel, we could produce power, and we can make more KITE engines out of the very plastic that we pull out of the ocean. And a local company called Protopasta makes a recycled PETG filament. I'm using this very filament for version 9 of the next KITE engine. I put the link down below if you want to try some. If you want to support the project, click like, subscribe. I've got a Patreon, and I posted the designs there and on Etsy, where I also have my mechanical wallets and little wallet-sized notebooks, and I use all the proceeds for research.
So while I port parts from version 8 to version 9, let me tell you a bit about the development process. I realize inventors really have to be project managers. They need to be able to take a big problem and then break it up into segments. So let me tell you what we're doing for the KITE engine. We're breaking the project up into 3 main parts, focused first on manual transmission, and then automatic transmission, and then full autonomous autopilot. So starting with manual transmission, we're really focused on hand crank and human powered. This mode is mostly for sailors, and we just want to see if all the parts work harmoniously, that they work together, and that the gears fit, and everything really just works as a unit. After the manual, we shift up to the automatic transmission. And at this stage, we're adding, the electric motors, the sensors. We're starting to gather more data. We've got the motor controllers. And with all these components, we can start working on the regen. And the regen is the ability to really put power back into the system. We're going to use a Grin Technologies display just for testing, so then that we can see all the power coming back into the system. And it really lets us be more aware of what's going on. Now, the ultimate goal is the fully autonomous autopilot. And this is the press and play mode. This is the mode that integrates all the parts from the manual stage and the automatic stage, mixed with a little bit of AI. But you should be able to press a button and basically the autopilot will take control and fly the kite. This mode will have all the things necessary for regen and just flying autonomously. So if you're going on a long crossing, you can engage the autopilot and go below deck and do whatever you need to do and have the kite system just take control. And this is also the mode that we'll want to see for any type of offshore wind energy operation, something where a person or a pilot doesn't have to be there all the time. It just runs automatically. So I made the mistake of assuming a kite would be easy to fly. This is not the case. I mean, even though kids fly kites, we don't realize how much a kid is doing computationally in their mind when they fly a kite. Things are easy. Things come easy to us, but it's hard to translate that into a machine. So let me explain why kites are so different. When it comes to a plane, planes have their own internal source of thrust, and that makes flying it and controlling it autonomously so much more computationally simple. You know that you have this constant thrust, you're going at this more or less constant speed. But for a kite, we're basically flying and relying off of gusts of wind, right? And it's very inconsistent. You know, we'll have lulls and we have gusts, and it makes controlling the system very difficult. So what we need is a very responsive system. What other companies will do is install expensive, heavy telemetry on the airborne unit itself, on the airborne kite itself. But this is something that's actually completely unnecessary. And it's also just a lot of extra, it's a can of worms. I mean, when you put the telemetry aloft, you've got to power that, you've got to run, you've got to send comms to that thing, you've got to waterproof it, and it's a lot of unnecessary information. I know that all we need is a camera, tension sensors, and to have a consistent length of line. And using all of these, we can train an AI model to first predict where the kite will go, and then to control where the kite will go. So this will involve hours and hours and hours of logging data so that we can train these models to fly the kite autonomously. So that's all I have for you this time. If you happen to actually be an expert on printed control boards, let me know. I've got some questions. But subscribe, because I'll be posting more consistently. I'll be talking to Dan Tracy, the pioneer of kite kayaking in the Northwest, and until then, I will see you next time. I'll see you at Open Sauce.